OK, in the last video, we saw how if you provide mismatch arguments to printf, printf will do weird things. And remember, when we say mismatched, printf uses its 0th argument to determine how many format specifiers there are, how many percent placeholders exist. And for every percent placeholder that exists, printf requires an additional argument that will match up with the percent formatter. And if you give printf a mismatched number of arguments, for example, the 0th argument has 5% signs, but you only provide 3 arguments to match with the 5% signs, weird things happen. Specifically, printf goes on the stack and tries to look for arguments, even though those arguments were not provided. And that causes unintended things from memory to be treated as arguments. And so in the previous video, we saw how you can use that to print out values that were not expected. And maybe a more general version of this attack is some code like this. So as always, we define some character array. We call it a buffer. And we allow the user to input 64 bytes. So here we're using the fgetAs function, which guarantees that once the user writes 64 bytes, we no longer read more user input. They are limited to 64. So at first, it seems like this should be totally fine. The user can only write 64 bytes to the character array of size 64. They cannot overwrite past the end of buffer. But what's the problem here? Well, the problem is, if I look at this printf function, it's taking in buff, which we're allowing the user to write, as its 0th input. And remember, the 0th input is critical, because the 0th input, the very first thing you pass into printf, that 0th input determines how many more arguments there should be. And when there's a mismatch, bad things can happen. So the problem here is we are allowing the user to control the input to printf, that critical 0th input. And if the user can control this, the user, and here the user could be an attacker, they might actually input some percent formatters. And if they input some percent formatters, then printf will try to match them up with non-existent arguments, and bad things can happen. So the problem here is we're giving the attacker control over that critical 0th input to printf.